PhD student at the University of Massachusetts, and today I'm going to talk about a software system called Rookie, which is designed to answer complex historical questions from news archives. Here's an example of the kind of question I want to answer with Rookie. In the last 2 decades, how has the US tried to convince North Korea to stop making nuclear weapons? What worked and what didn't? These kinds of questions come up all the time in journalism, both from journalists and from readers. This particular example comes from a New York Times podcast called The Daily just last week. News archives are a rich, detailed resource for answering this kind of thing. When I began working on this project, I was a software developer at an organization called The Lens in Louisiana. What a lot of people don't know about Louisiana is that it's suffering from dramatic coastal erosion, so that this map of Louisiana, which we're used to seeing, is going to start looking like this if things continue the way they're going. The Louisiana government has something called the master plan, which is designed to stop the erosion. And so a reasonable question you might want to know is the master plan properly funded? Is it scientifically sound? Is the government making sure that the money which is being spent to stop coastal erosion is being spent properly? Wikipedia does not have answers to these kinds of questions. If you go to the page for coastal erosion in Louisiana, you see a single document about the master plan. By contrast, if you go to the archives of The Lens, where I used to work, you'll find 129 stories. A lot of them are written by this guy, Bob Marshall, who's won 2 Pulitzer Prizes and has spent many decades covering environmental issues in Louisiana. The point of this story is that news archives have a lot of really good information in them, and it makes a lot of sense to design specialized tools for finding things in what reporters have already spent a lot of time and energy uncovering. The default way to search a news archive is actually pretty good. This is what you would get if you just tried to answer this North Korea question with the New York Times webpage using a standard search engine. You would just go in and type out something like North Korea nuclear weapons diplomacy, and the thing would come back with documents that magically told you what you were looking for. Search engines are great. They're very reliable. And if you think about language technologies, search engines work kind of all the time. It's a sort of magical technology. But search engines have some obvious limitations if you are trying to answer these kinds of complex historical queries. The first thing is that search engines don't give you any sense of time. So there were certain time periods when US negotiations with North Korea were more and less important. And there's nothing in a traditional search engine interface which would give you any sense of this information. Traditional search engines also return a lot of documents. This particular query returns 1,100 results. And it would be great if natural language processing could do something to condense those results so that people didn't have to read everything that came back. The final deficiency of a search engine interface is that they don't give you any sense of the who, what, and where associated with your query. In this particular case, there are names of particular diplomats and particular frameworks that are really important to US negotiations with North Korea. And there's just nothing in a traditional search engine interface which tells you anything like that. So our system, Rookie, is designed to answer some of these limitations with a traditional search engine. The interface is shown here on the right, and everything is grayed out except for this top part here, which shows that Rookie begins much like a traditional search experience, with a free text query. Our idea is that a user should be able to search for whatever they want in Rookie, and just like a traditional search engine, Rookie should always work. But things deviate from the traditional search experience pretty quickly. The most obvious change is this interactive time series, which we add into the interface. The interactive time series is very simple. It just shows you how frequently your query is mentioned across time. In this case, we're looking at 3 decades of the New York Times corpus. This really simple effect is quite powerful when you add this interactive visualization. So the user can scroll in on a particular time periods with this rectangular slider to investigate particular news events. The effect is directly inspired by Google Finance. And so in the same way you might want to look why a particular stock went down, you might want to look why are there all these mentions of North Korea in the New York Times in the late 1990s. The next thing we add is a collection of people, places, and organizations which are relevant to the query. And this answers the who and what, which is limited in a traditional search engine interface. In this sense, our system is similar to systems like Jigsaw and Footprints, which also provide this kind of information in a text analytics system. But our approach is quite different than the way people normally find the people, places, and organizations in natural language processing. The standard thing to do would be to use a traditional named entity recognizer, like something that you'd get from Core NLP, a typical NLP tool. Something like Core NLP, if it looked at this sentence, Kim Jong-il started developing ballistic missiles, would say that there's one named entity in this sentence, Kim Jong-il. But Core NLP would miss this other really key phrase, ballistic missiles. Our lab thinks that these key phrases tend to follow certain syntactic patterns, and we wrote software which extracts phrases that match those syntactic patterns very, very efficiently. We also wrote a paper that explains why we think this is a good way to approach these kinds of key phrases in documents. If you follow this URL, and I'm going to tweet these slides when I'm done, you can get a link to the phrase machine software and the corresponding paper. Another thing that our lab doesn't, or another thing that's not present in Rookie is topics. Topic models are a really popular way to browse news archives, seen in interfaces like TextFlow, Parallel Topics, and Tiara. The problem with topic models, for our case, is that they're just too coarse. If you want to answer this question about North Korea, nuclear weapons, and diplomacy, what you really want to know is that this particular envoy traveled to Pyongyang on this particular date, and they met with this person, and they talked about this, this, and this, and here's what didn't work. But a topic model, which returns a list of associated words, is not going to get you that kind of granularity. And so we don't include topic models in Rookie. The final piece of the Rookie interface is a query-focused multi-document summarizer. When I talked about some of the limitations of a traditional search engine, one of the limitations is that it just returns too many documents than you could possibly read. So we use a very simple summarization technique where we just rank sentences that are in documents from the query based on whether they contain query words. This is really simple, but it also runs very, very quickly, and it's easy to interpret. The user can scroll through the sentences to continue to learn more or drill down to the actual documents. So in this sense, our approach is very different from standard techniques for multi-document summarization within NLP. Any one of these individual components of the Rookie interface is maybe a nice additional feature for a search engine, in my opinion. But I think the real power of Rookie comes by combining these three components to give an interactive linked views of the corpus. What I mean by that is probably best understood by an analogy with structured data. Linked views are a common way to explore structured information. So the basic idea is to provide multiple views of the same underlying data set from different perspectives. In this case, we're looking at 4 scatter plots of the same data, which are aligned along different dimensions of the data. And when a user goes and selects some of the data in one of the view, the other views update to reflect the change. This is a sort of classic way to interact with structured data. But what we're doing with Rookie is we're applying this to text. Instead of this little rectangular slider here, we use a triple, Q, F, and T. Q is the search engine query, F is the related subject, and T is the time span that you're interested in investigating. We think that this is a powerful way to explore news corpora, and the reason we think that this is a powerful way is that we tested how quickly actual users could answer complex historical queries using this interface. We asked users on Mechanical Turk a complex question about Haitian politics, concerning the United States and the Haitian political figure Jean-Bertrand Aristide. We asked them a multiple choice question with 4 options. Jean-Bertrand Aristide is a longtime ally of the United States. Jean-Bertrand Aristide is a longtime opponent of the United States. Jean-Bertrand Aristide was first an ally and then an opponent of the United States. Or Jean-Bertrand Aristide was first an opponent of the United States and then an ally of the United States. This question is really hard. You have to go and search through hundreds of documents, find information in them, read it, synthesize it, and generate a new answer. It's a difficult task for humans, and there's no single factoid answer in the corpus that's going to tell you what you're looking for. We gave one group of Turkers a traditional search engine interface shown here, and we gave another group of Turkers the same question with the same documents with the Rookie interface. And we showed that people using Rookie answered this question correctly in 37% less time than people who were using this IR interface. This gives us confidence that there's merit to the Rookie approach. We also conducted a qualitative evaluation with undergraduate journalism students in the University of Massachusetts, where we showed them Rookie and asked them to comment on the advantages and disadvantages of the system. They liked using Rookie and said things like, "Rookie made me feel like I could find things that might be buried in a more traditional search engine." In the remaining time that I have left, I just want to give you all a brief sense of Rookie by doing a live demo. In this case, what you're looking at is a corpus of New York Times articles. The user has done a query for Bashar al-Assad, and Rookie has returned this time series graph showing the relative prevalence of Bashar al-Assad through time. Immediately, you can see that Bashar al-Assad really enters into the news from 1999 onwards. So you can click here, just like in Google Finance, and zoom in on this particular time period. These three interactive linked views give an overview of the corpus from multiple different perspectives. Here, we see the who, what, and when of the query. It tells us that this person, Hafez al-Assad, is closely linked to Bashar al-Assad during this particular time period. The summary view now updates to show the relationship between Bashar al-Assad, Hafez al-Assad during this time period. If the user wants to investigate an individual document, they can click to go read the actual text. This gives a really powerful effect that I think is unique to Rookie, where you can open this rectangular slider and scroll across time to read a summary that updates. So what you're looking at here in the bottom right hand of your screen is Syrian history related to Bashar al-Assad from 1998 all the way to 2007. And it's really, really easy to see the changes that have occurred through time. That's pretty much everything I have to say about Rookie. Thanks a lot to a bunch of people who helped me develop Rookie. I'm going to, again, tweet out these slides at the end of the presentation, and you can learn more about the project at this URL. I should mention that the initial prototype of Rookie was supported with a grant from the Knight Foundation, which was really instrumental in allowing me to even begin the project. I think I have a couple minutes, so if anybody has any questions, I'd love to hear what people say.